Okay, before I quickly go over the lesson that we discussed yesterday, I just want to go over what you need to do today. I'm going to be doing some practice problems with you over section 3.2, which discusses logarithmic functions and their graphs. Again, we talked about this yesterday, and I believe we even wrapped up the lesson yesterday in one day. You are responsible to turn in the examples that we do together via the video. So whenever you're done, make sure that you turn these into the substitute before you leave for lunch. If I do not get one from you, it is an absolute zero, no excuses. It is your responsibility to make sure that you actually turn it into the substitute. Again, you need to turn it in. As a reminder, what do we do or what do we write in whenever you turn in something into me? It needs to be in pencil. It needs to be in pencil. If you don't have a pencil, you need to ask somebody for a pencil because nobody will be allowed to go anywhere near my desk. In addition, a reminder that no one is allowed to work on their project or even touch anything in regards to their project. I don't want any accidents to happen while I am not there. However, I will be back. I'm only going to be gone for fifth period. I will be back by the end of the day. So if you're interested in staying after school to work on your project, you're more than welcome to stay. I will be staying. I know that it is the weekend at the end of the bell. However, I do have some students in sixth period that wanted me to stay. So I will stay if you need me to. I'll be here. All right, so let's quickly go over the lesson from 3.2, logarithmic functions and their graphs. We basically said that the relationship between a logarithmic function and an exponential function, which is what we discussed on Monday and Tuesday, was that they are inverses of each other. Okay, and we also had the two definitions. You had the first one, which is y equals log of x base a. That is the log equation. The second one is the exponential, which is a to the y equals x. And I can take a log equation and rewrite it as an exponential, and likewise I can take an exponential and rewrite it as a log equation. We also mentioned that for calculator purposes, the log button is always with a base of 10, and that can sometimes change, and that's the next lesson where I will show you how to change bases. However, with the natural log button, it will always and forever be in what base? Base E, exactly, which is a constant, 2.71828. And again, that button is on your calculator. We also did some quick examples where we had the log of 8 base 2 is equal to something, and all you do is match up the letters and rewrite it in exponential. After that, we had the exact same example where we said log of 8 base 2, but this time it doesn't have an equals. What do? We basically say it equals to x. Again, after we said equal to x, we solve for it. This is a one-to-one property. So that means we have to rewrite one of the sides so that it can have equal bases. And finally, we set the exponents equal to each other. We went over some properties of log, which by coincidence is also the same kind of properties that you use for natural log. Let's go over them together. The log or the natural log of 1 will always be 0. The log of a, of base a, so in other words, the same value, will equal 1. The natural log of e equals 1. And if we look at the third one, the natural log of a to the x of base a, well, it's simply going to equal that exponent. And same for this one. Okay, we continue with these examples. With this one, we had to change that 1 over e as natural log of e to the negative 1. Then after that, it becomes one of the properties. It actually becomes the third property. So our answer is negative 1. This one is also the exact same thing. We don't need to manipulate the e squared because it's already on the top. And with that said, we know that the answer is automatically 2. Okay, we also can go from exponential to log equation. Again, match up the letters, and then you just write the equation out. Same thing for e. Match up the letters, but in this time, instead of using log, remember I said that you need to remember that every time you see the e, you're automatically using what? Natural log, exactly. So match them up, and that's what you get. Finally, we did a graph of these values, natural log, and we found out that, first of all, we can't take the natural log of a negative number or 0. Then we finished the rest of the values and got those following y values. After that, we plotted them, and you got this exponential curve. Now, if you think about it, I asked you for what the domain is, and if you look at your x and y table, well, where do we start getting a domain? Anything after 1, right? So in other words, my domain is anything that will be greater than 0, and that's what our domain was. After that, I just visually showed you that the exponential curve, which is what we did here, is the inverse of the log equation. And when we have inverses, what happens with both of those pictures? It's basically a what of each other? Right, it's a reflection, or in other words, a flip, exactly. So as you can see, this is the reflection right there. Okay, and then we had this example where you had y equals b plus or minus log of bx plus c, base a. And then you have the following equations. To get the domain, you simply set the bx plus c, which is your part in the parentheses, greater than 0. To get your VA, or vertical asymptotes, you take that exact same thing and set it equal to 0 and solve for x. And then to get the x-intercepts, you still take that bx plus c, but this time you set it equal to 1, and you solve for x. So we did an example. This one, our bx plus c section, is the x minus 2. So I say to get my domain, x minus 2 is greater than 0. Solve for x, I get x is greater than 2. To get my vertical asymptotes, I set this x minus 2 equal to 0. Solve for x, I get x equals 2. To get my x-intercepts, I set x minus 2 equal to 1. Solve for x, and I get x equals 3. Finally, you graph what you get, and you find your x-intercept to be at 3, your vertical asymptote to be at x equals 2. That's why it's called a vertical asymptote, because it's a vertical line. And then finally, you sketch your exponential curve. Okay, so that's the lesson that we learned yesterday. Now what I will do is I will continue with some example problems from the book. So let's start off with number 1. Let's make it a little bit bigger. Number 1 says, write the log equation into exponential. So write log equation into exponential. And here is the log equation. It is log of 64 base 4 So log of 64 base 4 equals 3. Okay, the first thing you need to remember is that this is in log form, and if I remember correctly, the way that I express this was log of x base a equals what? Y, exactly. Okay, so now that we've written our log equation and we've realized that it's in log form, let's just match up the letters. So I'm going to say that this 4 matches up with the letter A. That's exactly what I'm going to color it. Then I'm going to say that the 64 matches up with the X right there. And then I'm going to say that the 3 matches up with what? Exactly, the Y. So I'm going to make that green. Okay, and then after that, we want an exponential form. And if you remember correctly, exponential form is what? A to the Y equals what? X, exactly. So I'm going to recolor my letters. So the A is red, the Y is green, and the X is purple. Okay, so now what's left to do? All you need to do is just match up your letters or your colors, if you want to use that, say that, and rewrite them in, substitute them in. So here we go. So our new exponential form, let me go ahead and copy and paste that. So I will have A is 4, Y is what? 3, exactly, good job. And then X is what? 64, excellent. So we have 4 cubed equals 64, and that is exactly what our rewritten expression is in exponential form. So I'm going to highlight that so that I can show you that that is my answer. 4 cubed equals 64. And if you type 4 cubed in the calculator, you do get 64. So that is the correct response, because all we're doing is just simply writing it into exponential. Okay, let's look at number 5. Number 5 is the exact same instructions. So write log equation into exponential, and we have, let me go ahead and copy and paste this one. So we have log of 32. So this will be 32. This will be 4. So we have log of 4 base 32 equals 2 over 5. And again, all we're doing is rewriting, so you shouldn't freak out that you're seeing a fraction. Okay, so if we match up the letters, let's go ahead and just place our log equation underneath so you can match up those letters. Okay, letter A represents what number? Or letter A represents what number? 32. X represents what? 4, that's right. And Y represents what? 2 over 5, correct. Excellent. Okay, so now we need to rewrite it in exponential form. So I'm going to go ahead and copy and paste my exponential format, which is a to the y equals x. And the last thing you just need to do is just go ahead and substitute what those letters are. So in this case, my a is what? 32. My y is what? Excellent, 2 to the 5th. So 2 over 5. And let's go ahead and just start placing those in parentheses. So 2 to the 5th. And then my x equals what? 4, exactly. And that is my answer. All I did was just write from logarithmic equation into exponential. Perfect. Okay, and let's practice one more of those. You have number 8, which are the same instructions. Write log equation into exponential. And again, I probably didn't mention this at the end, but if I'm going too fast, make sure you tell the sub to pause it so that you can copy everything down before we move on to the next one. Okay, so we have write log equation into exponential. So I have my exponential form, which is log of 4 base 8 this time equals 2 over 3. Okay, so go ahead and write that one down. It's log of 4 base 8 equals 2 over 3. Now, my time is about to end for this first video, so I'm just going to go ahead and let you finish write that one down. And I'm going to continue as soon as I upload this one onto YouTube. I will continue with a part 2 where I have a couple of more examples to do with you. So hold on tight while the sub goes to the next video, which is part 2.